Okay, let's take a look at this homework. Practicing drawing these graphs. We're looking at the first one, 1a, y equals quantity x minus 1 squared minus 7. So looking at the key points here, we see this vertex staring at us. And then we're also looking in front of the entire equation to see, like, what is my stretch right here and what is my orientation. And so when there is no number in front, what invisible number do we know exists? You got it. There's the 1. Stretch is 1. That means that it's the same as the parent. Then my orientation is positive or upwards. And then my horizontal and vertical shift, those directly affect my vertex. So my vertex is going to be a 1, -7. And my horizontal shift is going to be right 1 and down 7. Those are the movements from the origin of where I'm originally starting. So here we go. Let's go put a dot on there. Now I need to label and scale all these graphs. There's X and Y. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, -10, and -10. So we're going to go put a dot at the 1, -7 mark. 1, 2, 3, 4, 5, 6, 7. So there's my vertex at 1, -7. Now from that vertex, I'm counting the parent growth. A stretch of 1 means the normal parent growth. So my normal parent growth goes out 1, up 1, out 2, up 4, out 3, up 9, and out 4, up 16. Okay, and then go ahead and connect that graph as best you can. Hopefully it looks a little bit better than my connection there. Let's try this one more time. Okay, finishing off this graph, don't forget about the line of symmetry. That's going to go straight through the center of your vertex. And so my line of symmetry is red on this graph, is straight through x equals 1. Okay, how'd you do? There's your first graph. Let's go do the next guy. Okay, next one we're seeing here this time, I can identify this as the critical point of my graph, the vertex. So go ahead and try it. What do you think it is? You got it. That's my vertex of -2, +8. Remember that if it's an x plus 2 in this equation right here, it's an actual left 2 horizontal shift. Because that x value inside the parentheses, it's going to have the opposite effect. So this is left 2, and the vertical shift is up 8 from my original dot at the origin. So here I go putting that on there, left 2, up 8. And that's going to be my starting vertex. Make sure you've labeled and scaled the graph. And our stretch this time is also a 1, same growth as the parent, but our orientation is flipped. It's down because of that negative sign in front right here. Okay, so let's go grow our graph down the same as the parent graph. All right, this one's going to go out 1, down 1, out 1, down 1 from that vertex, out 2, down 4 on both sides, out 3, down 9, and out 4, down 16. And connect it. Okay, to finish off my graph, I'm going to go grab the red again. We're going to finish with that line of symmetry straight down the middle of that parabola. That's my LOS, my line of symmetry, straight through the vertical line x equals -2. And that's my line of symmetry. How'd you do on that graph? Okay, remember to pause the video and try things on your own. See how you do. Let's go check out this next one. See if you can fill in any of these missing features. Okay, did you see this time that the horizontal shift is right 5 because of that x minus 5? But there's no number at the end. I could essentially call it +0. So my vertex is at 5, 0. That means that there is no vertical change. We call that vertical shift none. My stretch is 2. My orientation is positive or upwards. Label and scale that graph. Go put that vertex at 5, 0. From there, we're growing a graph upwards 2 times as fast as the normal parent. So out 1 would normally be up 1. We're going out 1 up 2. Out 2 would normally be up 4. We're going up 2 times the normal 4. We're going out 2 up 8. And that's all I can fit on my graph. Connect it. And that graph with your line of symmetry going straight down the middle of your vertex. That's your line of symmetry through the line x equals 5. How'd you do? All right, looking at this next guide, you see the horizontal shift this time is left 4 because of the x plus 4. Vertical shift is down 3. So therefore my vertex is -4, -3. My stretch is 1/2. My orientation is positive or upwards. Label and scale. Go put that dot at -4, -3. From there we go half as fast as the normal parent. So out 1 would normally be up 1. I'm going to go out 1, bloop, up 1/2. Out 2 would normally be up 4, so I'm going to go out 2 and up half of 4, only up 2. Out 3 would normally be up 9. I'm going to go up out 3, up 1, 2, 3, 4 and 1/2. Out 4 would normally be up 16. I'm going to go out 4 and go up half of 16, which is 8. And you can stop there. You can keep going and see if any more dots fit on there. But connect that graph and draw me that line of symmetry. That line of symmetry goes straight through x equals -4. All right, if you haven't yet, pause the video and try to do these on your own. Okay, let's see how you did. Horizontal shift of this one is right 2. Vertical shift up 5. My vertex is at 2, 5 then. Excuse me. Okay, my stretch is going to be an invisible 1. There's no number there, so it's just 1. And my orientation is down. Label and scale that graph. Go put that dot at 2, 5. Right 2 up 1, 2, 3, 4, 5. From there, we're stretching down at the normal parent stretch. Out 1, down 1. Out 2, down 4. Out 3, down 9. Etc., etc. How'd you do? Connect that graph. Draw me your line of symmetry. That line of symmetry this time goes straight through x equals 2. This next one has a horizontal shift of left 1 and no vertical shift. There's nothing at the end there. That means that -1, 0 is my vertex. Stretch is 1/2. Orientation is upwards. Go ahead and put that dot. Oh, just kidding. Go label and scale. So I'm going back 1, 0. From there, I'm doing a half as fast stretch. So out 1 would normally be up 1. I'm going out 1 up a half. Out 2 would normally be up 4. Out 2 up 4. Oh, half of 4. Out 2 up 2. Out 3 would normally be up 9, so I'm going out 3 up 4.5. Look at how slow this is growing. Out 4 up 5, 6, 7, up 8. 8 is half of the normal 16. This graph is growing half as fast as the parent graph. This is my line of symmetry. It goes directly through x equals -1. All right, I'm going to speed through these last 4. Please pause the video and you try them on your own, and then let's see how you do. -6, 7 is my first dot. From there, I'm going down 3 times as fast. So out 1, down 3. Out 2 is normally down 4. 4 again. 4 again, that's going to be 12. 4 times 3 is down 12. Connect that graph. Skinny graph, drawing that line of symmetry. That line of symmetry goes straight through x equals -6. How'd you do? Next one's got a horizontal shift of right 3. Vertical shift of down 6. Orientation is up. Stretch is 4. Vertex is +3, -6. How'd you do? Label and scale. Graph it. Right 3, down 6. Out 1, up 4 times the normal parent. Out 2 is normally up 4. 4 times 2 is 8. Very steep, skinny graph. Oops. You guys see what I did wrong there? When I tried to connect it, it didn't make sense. I went 1 over on that guy. Good catch. All right, drawing that line of symmetry. Straight through x equals 3. Last but not least, this one has something weird. I could rewrite it as x minus 0 squared. Does that make you feel better? There is no horizontal shift. Vertical shift is down 2. Orientation is still up, positive. Stretch is 1/3. My vertex is going to be at 0, -2. It's right on the y-axis. That's okay. There's my labels and scales. Go ahead and put that first dot at 0, -2. From there, I'm stretching up 1/3 as fast as the parent. Out 1 up, boop, like literally. Let's zoom in. So 0, -2. Out 1 up 1/3. Out 2 up 4/3. Out 3 up 3. That's a nice one we can hold on to, connected. Put in that line of symmetry, and you're done. Yes, the line of symmetry can go straight through 0. It is allowed. It's right on the axis. Our last one, how'd you do? Pause it and try it. Okay, let's see how you did. Horizontal shift this time is a left 2. You got it. Vertical shift is an up 10. That means my vertex is at -210. My stretch is 2. Remember, there's no negative there. My orientation is down. Label and scale. Oops. -2. Up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, dang. Way up there at the top, and then it's growing down 2 times as fast. Out 1, down 2 times the normal 1. Out 2, down 4 as usual. I'm going to go down 8. Out 3 is usually down 9. So I got to go down 16. No, 18. Hey, it fits. Check that out. Connect that skinny downwards facing parabola and draw on that line of symmetry. Are you getting better at this? How are you doing? My line of symmetry goes straight through x equals -2.